everything you learn? Why do we learn the formulas and how to solve things, how to do things? What's the end goal? Yeah, I think this one. To understand how to solve this in your everyday life, right? You might not be the person who's going to design a bridge, right? You might not be the person who's going to design a fountain where a fountain needs to go, the water needs to splash in an archway, right? But you might, right? When we're teaching this, you might not be the soccer player or the football player or the analyst or whoever it is that's trying to kick a ball and make sure that it gets into that hoop or into that basket or into that net or whatever it is, right? But you might be, right? And this is where we all have to learn. So we have to learn not only how to solve quadratic, but how to solve problems, no matter what the problems are. Okay? The problems could be solving quadratic, they could be solving finance, it's just the critical solving behind it. How do I use the information given to find my answer? Okay? And if you're going to get out of this high school or of any high school or of any school with something, it will be how to solve problems, no matter what they are. Okay? How can I take this information to find my answer? Okay? Now, we have an arc, and that's the St. Louis arc, and they've designed it in a way that looks like a parabola to me, doesn't it? Right? Can you guys see it? It's a little bit dark, but there is this arc here, and it's a parabola. Okay? Now, what they did here is they put an x and y axis, but they made the x and y axis kind of centered. The beauty of this is if you are the person who's trying to solve this, you have the option to put your x and y axis passing through your vertex. You have the option to put your x and axis through here, as long as you define where you want your x and y axis to be. Okay? Now, they put the x and y axis, I don't know if you guys see this, but they put the x and y axis going through the vertex. Okay? So this is where the x-axis is, and this is where the y-axis is. And they want to know, this is the grid where it has been superimposed on the gateway arc in St. Louis. They want you to find the equation that model the arc. So what do they want you to find? What's the question asking you for? Find the equation. When did we do something like this? Yesterday.
So we have to look for h and k?
You have to look for h and k, which represents what?
The vertex.
The vertex. Okay, so I have to know what my vertex is. What else do I need? Another point, x and y. Good. So these are the information that you have to look for first. Okay? Now what's your vertex? 0, 0, because your vertex is right here at the origin. Right? So your vertex is 0 and 0. Okay. So you know that your vertex is 0, 0, and that's your h and k. You guys told me that, right? You told me that you're looking for h and k, which is your vertex. Now what other point do you need, or what's given to you, or which one to use, or whatever? -3 and -4. That's one point that they gave me, right? Now, would it matter if I use 3 and -4? Does it matter which one I use? It shouldn't, right? You're going to end up with the same answer no matter what point you use, as long as that point is on your arc, right? Even if I come and say, well, I don't want to use these points, but I want to use this point right here, and this point is on my arc, as long as it is exactly on my arc, I can still use that. Okay? But if they give you 2 points, why would you go and look for something else? Pick one of these 2 points and use them, because you know accurately that this is on the arc. Okay? So you can pick either this point as x and y, or you can pick this point as x and y. Okay? Now where do I start? What do I start with? So I define my points. Okay? I define start first? What do I write first? The vertex form. I have to start with my general vertex form, which is everyone. What's the general vertex form? Good. So remember this. If you can't remember it, where can you find it in the classroom? On the green sheet, or there's another spot for it. Right there. Right there behind me. Right? Use your resources. Good. Now I wrote my general form. Now what do I do with it? So hands up.
Plug in the numbers.
Hands up, please. Prince.
You gotta plug in the numbers.
What numbers? Where do I start? What number do I start with?
H and K.
H and K. So first you're gonna have to plug in your H and K. Okay? Which is? So it's gonna be 0 squared plus 0, right? Which I don't literally need to include, like, because what's x minus 0? Just x, right? And then you're adding a 0, there's nothing, right? So I can simplify this to look y equals ax squared, right? Because x minus 0 squared is just x squared, plus 0, that's nothing. Okay? Now, I still have to look for a. And how can I do that? Sorry, guys, I would like you to put your hands up, please, if you have an answer. And take your time to find an answer. I mean, I'm not in a rush. How can I solve for a?
You gotta find X and Y.
So I have to use x and y,
Yeah.
okay? And what do I do with the x and y? Plug them in, right? I have to plug them in.
Yeah.
So which point do you want me to use? The -3, -4, or the 3, -4? It doesn't matter? No? So let's use this one?
Yeah.
Okay. So the point is 3 and -4. So that's x and y. Okay? So I'm going to plug in x as 3, y as -4. So that's going to be -4 equals to a times 3 squared. 3 squared gives me 9a. And then, how do you isolate for a? Bring it over and it becomes -4 divided by 9. Right? Because you have 9 times a, bringing the 9 over, that's going to be division. So that's going to be -4 divided by 9. And you leave it as -4 over 9. It's okay. Okay? It's okay to report your equation with a fraction. So that's going to be y equals -4 over 9 x squared. Now my question to you, when you looked at your a, the value of a turned out to be negative. Does it make sense? Why? Because there's a reflection. The arc is opening downward, right? So your arc is opening downward, which means I'm expecting my a value to be negative. This is critical thinking. This is me reflecting on my answer and then making sure that my answer makes sense, right? Am I done?
No.
Did I find the equation? Yes.
You gotta write it down.
It's written. It's right here. Look at it. I've already written it out.
You gotta like plug it in with the Y. Like write the whole equation out.
Well, I don't need to include the zeros. The h and k are zeros, so I don't have to include them. So that's it. That's it. Right? That's my final answer. Okay? H and k, sorry, are 0, 0. And then my a value turned out to be -4 over 9. Done. Yes? What if someone reported their answer, and don't write this down, please. What if someone reported their answer as -4 over 9x? Sure. should I give them marks for this? Why not? Yeah, then I don't have an arc anymore, right? If I actually graph this on Desmos, that's going to give me a straight line. Yeah, that doesn't look like straight. But it's going to give me a straight line. Right? Because this is degree 1 right here. Right? So this is not a correct answer. Be careful, guys. Be careful what you report, right? Go back to the degree 2 means quadratic. So I have to have the degree 2. Don't forget. Because imagine you go and tell you're the architect, right? And then you made that mistake and you reported it to your construction company as y equal negative 4 over 9x, and they go build an arc and they build it as a straight line. That would be beautiful, doesn't it? Right? Little mistakes. Here's another example. So what do we have here? So football was kicked. Its path can be modeled by the relation h equals negative 0.1 d minus 8.7 squared plus 7.6, where h is the football's height above the ground and d is the horizontal distance from where the football was kicked, both in meter. So I'm not using x and y here, am I? Do you see x and y in your equation?
No.
What do you see instead of x and y? D and H. What's H? What letter does H replace?
Y.
Y. What letter is D replacing? So you see, yes, I can change the y and x. Y and x is just for me, just as a rule, as the basic, right? But then if I'm talking about height and distance, why do I want to use x and y? I can use h and d if I want, as long as I report to you what h represents and what d represents. And I did, right? I said h is the football's height above the ground and d is the horizontal distance. Okay? So what you're looking right now, you're looking at the football. The football is going to go up and then it's going to go back down. Right? Where this right here is the height of the football, and this right here is the distance from where he kicked it. Okay? So I know that it's going to land a certain distance away from the kicker if no one catches it. Yeah? Now, why did I draw it as a quadratic? How do I know that it's going to be a parabola? Other than it makes sense. What's the equation tell me? How do I know? It's a square, right? You see that square right here? It's a square. It's a degree 2, right? Now, why did I, other than it makes sense that the football is going to go up and then go back down, what tells me that it's going to open downward? The A is what? It's negative, right? So looking at my equation, that should make sense because A is negative, quadratic, it makes sense. Oh, yeah. Now the question is asking you, what form is this written in? What form? Standard form, vertex form, factored form, what form? Vertex form. Vertex. Yeah. Now, what's the vertex of the parabola? Ahmed.
8.7 and 7.6.
8.7 and 7.6. Do you agree with Ahmed on this?
Yeah.
So the vertex is 8.7. Because it's a vertex, I have to write it as a point, guys, right? So it has to be in brackets with a comma. What's the football's initial height? We haven't talked about this yet. But what does it mean by initial height?
Like that.
Where would that be?
The ASIN.
Where it started from, right here, right? That's the initial height. Now, the initial height is not, it doesn't have to be on the ground, right? I drew it like this, but it doesn't have to be on the ground. It could be on the kicker's foot, it could be on a whatever. I don't know what they put it on, honestly. I don't watch football or play. Okay? But it doesn't have to be on the ground. It could be like a little bit lifted off the ground. How do I find my initial height?
Find the x-intercept.
Okay. You have to find an intercept. Yes. But let's see which one. So if I'm drawing this, right? And I'm drawing like my graph is going to be going up like this, right? The initial is where I started, right? Which is, what do we call that?
The y.
The y-intercept. So you do have to find the y-intercept. Always. Whenever you're looking for your initial, you're finding the y-intercept. Now, if you go back to the review that we did a few weeks ago, y-intercept. How can I find a y-intercept? Yeah. Yes. And how do I find it though? What's the value of x at the y-intercept? 0. Right? So my x, if you look here, right, this is my x, the value of x for this point is 0. So it's 0 and whatever the y value is. So for me to be able to find the y-intercept, I have to plug 0 for x. Remember, we did that even with a straight line. When we found the x and y-intercept, we said, to find the y-intercept, you plug 0 for x. Okay? Now, which one is x in this case? What letter is x? D. D. Okay, so let's plug in 0 for D. Because D is representing my x. That's a minus here. What do you want me to do? But do bed math. Brackets first, yeah. So 0 minus 8.7 is just negative 8.7. Right? Now, what's after the brackets? The exponent. What's negative 8.7 squared? I don't have a calculator. What's negative 8.7 squared? 75.69. Okay. Then, after I did the exponent, then I have to do.
Is that a 6?
Yeah, it's this. Okay. Then I have to do multiplication. So negative 0.1 times 75.69. That's going to be 7.569 negative. Did I lose you guys, or are we okay with this?
We're good.
We're good? And then what's negative 7.569 plus 7.6? 0.031. So what's the initial height of the football? Meters, right? Because if you go back here, it says the height of the football above the ground, it says, should say somewhere, was both in meters, right? So the height, the initial height is 0.031 meters, which is very, very close to the ground, right? Yes. Is that a? Because you see this one, h equals negative 0.1 times 75.69 plus 7.6, right? So when I multiply the negative 0.1 by the 75.69, I'm going to get negative 7.569.
So basically just plug in the zero for the units off.
That's right. Are you okay with this? So the initial height, you can say a therefore statement. Now, when do I say a therefore statement? When do I have to include the therefore statement? In a word problem. Okay? So anytime I'm asking you a word problem, I'm looking at therefore statement. So I'm looking for you to tell me, therefore, the initial height of the ball or football is 0.031. I don't know what's going on with this.
What are those things opposite?
Therefore.
Therefore.
Yep. Any questions about this? All right. What is it? I just sketched it. I didn't graph. So the difference between a sketch is just, just graph it just quickly to see if it makes sense and how it's going to look like. A graph, that means I'm looking for certain points. I'm looking to see your points, okay? So that's when I say sketch, I expect something like this, right? With a little few details. But when I say graph, I'm looking for, specific points. Okay? So what do I know so far? I know the vertex, yeah. What else do I know?
The initial height.
I know the initial height. What do we know about a parabola in general?
It's a curve.
It's a curve. What else? Smooth. What else? Symmetrical. Right? These are words that you need to use, you need to know, you need to remember when it comes to graphing. Right? Because so far all what I know is this. I know I have I know I have a vertex somewhere. Don't draw this point. I know I have a vertex somewhere, right? And I know I have an initial point, but that's not enough for me. So I know I have an initial point and a vertex, but that's not enough information for me to graph the whole parabola, right? That gives me only, don't sketch this. That gives me only this part, right? I need the other part. But because I know I have a symmetry and I have a smooth curve, where do I expect my next point to be? Huh?
0.3.
I expect it to be at the height of 0.03, but where?
On the other side.
On the other side, equidistant, right? So from here to here, I should have exactly the same distance as from here to here because of my symmetry. Now I'm going to graph this properly. I'm just showing you, I'm just telling you what you need to think about, right? So what I need, and this does not look equidistant at all, right? But what I'm looking for is I need to make sure, because I know it's symmetrical, I need to make sure that my point from here to here, it's going to be exactly the same as my distance from here to here. Okay? Because I know it's going to have to be a symmetrical, smooth curve. Good. Let's locate my point. Now, the points are a bit weird. I know that. So, this is distance, right? So this should be D, and this should be H. And you should probably also put like meter, height, label your graph, right? And this is distance in meter. I can go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I can go up right? I'm using this, you can use whatever you want to use, but this is, I need to make sure that my points fit, right? I know that the middle of my x-axis is going to be at 8.7, right? So I know that 8 should be somewhere in the middle of my axis, okay? This is how I decide on my scale. Okay? So my vertex is at 8.7 and 7.6. So if this is 8, 8.7 is kind of closer to 9, right? So it's going to be somewhere right here. And then 7.6 is about here. So that's going to be almost okay. Then I know the initial point was what? 0 and 0.031. Okay? If this is 1, where do you think 0.031 is going to be? Like close to the origin, right? If this is 1 meter, 0.031 is going to be right almost at the origin. Now, where would the third point be? I want an exact value. So where's your axis of symmetry? At what? Where's your axis of symmetry? What's your vertex again? Guys, the vertex is right there. What's the vertex? 8.7 and 7.6. So your axis of symmetry is at 8.7. So that means the distance from here to here is 8.7, yes? So that means my distance on the other side has to be 8.7. What's 8.7 plus 8.7? 0.4. 17.4. So I'm going to go a little bit outside here. Okay? So my next point is going to be almost right here. Right? Because you want this to be exactly the same as this. Does it look symmetrical to you? Smooth. vertex represent in terms of the football's path?
Peak height.
The highest point, yeah. The highest point that the football is going to reach. Right? What? What? The last number is 17.4. Right? Because from 0 to 8.7, right, there's 8.7, and I have to add another 8.7 here, right? So I'm going to end up at 17.4. Okay? So the points that I will have other than 0.031, I'm going to have 8.7 and 7.6, and I'm going to have 14, keep saying 14, 17.4 and 0.031. Right? So these are my 3 points. 1, 2, 3. How do you guys feel about this? What? Is it that hard?
You just threw me off when you went from H and G to X and Y instead of E.
Just if you feel like H and D are bothering you, just change them back to X and Y. Like you see how I wrote for you right here, instead of H and D, I put like on top of it X, Y, and X, right? Do that if that helps you. Okay?
Can you go to the bottom again?
Of course. All right? So here's what you're going to do. Let me just turn off this.